Good evening, guys. So we are going to look at the Bifrost graph editor today. We're going to be looking at working with strands. Sitting here in the studio, we've got a Corova milk porter and a very nice AJ Fernandez San Latano Requiem Maduro cigar. So we're going to sit back, enjoy ourselves, and make some art here. To start, let's open up our Bifrost graph editor, and if for some reason this is not appearing in your options, I would like you to go to Windows, Settings and Preferences, Plugin Manager, and we're going to pull, sorry, we've got multiple screens here, let's pull this up. We're going to scroll way down in our plugins. Here we go. Did I pass it? There we go. And we're going to just click loaded and auto load for all of our Bifrost, and it'll all start with Biff, short for Bifrost. Funny story, it's actually pronounced Bifrost. It is a Danish word. I don't make the rules. So let's create a new graph. And like I said in class, you guys can just kind of follow the recipe if you need to. So I'm going to hit the tab key. We're going to create a torus. And so we'll create a mesh torus, like so. I'm going to scale this so it's easier for us to see kind of what's happening both on screen and on the graph at the same time. I'm fortunate that I can work on a big 72-inch monitor here. So, again, you won't generally see what's going on until we connect to output, and I like to connect to output so that I can at least see what's happening in the space. Let's change the major radius to our torus here to 40, and I'll change the minor radius to about 6, and so zoom out a little bit. There we go. So we've got ourselves a nice torus on screen. Next thing we're going to do is we're going to hit tab key, we're going to create a vector field scope, and so I'll just type in vector here, and as you see, we get a bunch of options, and we'll pull up the vector field scope. Before we connect everything up, let's make two more fields that we're going to need. One will be a noise field. I like to use the curl noise field for this particular function. And we're going to need a scale field to kind of bump up the power of this curl noise field. So again, hit the tab key, pull up our menu, and let's do a scale field. Now be aware and be careful, because there is a scalar field, and that is very different from a scale field. Sorry, I just hit the microphone here. Hopefully didn't make you guys go deaf. So we want to make certain that we're using the scale field and not a scalar field. All right, so as of right now, let's start connecting this stuff up in a way that's going to give us some visual output. Let me scale this monitor here, this screen, so that we can maybe see what's going on. Alright, that should be okay. Kind of like that. So, one, any mesh that we're using to drive this strands sort of function will go into our probe geometry node. Next, we're going to connect our curl noise field into our scale field. And then our scale field will connect into our vector field like so. And then we'll connect our diagnostic geo output to our output right here. Whoops. Like so. Like so. There we go. I don't know why. It took a couple of tries there. So for now, this is what you should be seeing. I know it's not terribly exciting. However, we're going to change a few things that will give this a bit more life. One of the first things we're going to do is here under our scale field, we're going to change the scale of the field. Let's just go for now. And once again, these are numbers that you can play with until you get the result that you like. But I'm going to do 10, 10, 10, like so. You can make these asymmetrical, so you could do like 9, 4, 12, whatever you want. I mean, any numbers can go in here as long as you kind of like the result. That's up to you. They're all going to give you very different visual results. So it's okay to play around with them and experiment and get a feel for them. The next thing we're going to do is really important. Down here in the vector field scope, let's scroll down to the bottom, and we're going to make certain that we tick the box that says display flow lines. And if you notice, when I turn them on and off, it's basically showing the vector field scope accepting this curl noise field as it's piped through the scale field over time. And it's 24 samples per second. And then now when I turn the display flow lines on, I can decide how many seconds it's sampling it. We're going to set it right now just for about 10. And look at that. We get this sort of really beautiful, I think beautiful, elegant spaghetti bowl, whatever you like to call it, right? And once again, it's this curl field amplified by the scale field being sort of populating itself inside this torus mesh. And then the vector field scope is imagining what would happen if I stretch these flow lines out over 10 seconds through this field. And that's what we get. If we change this to 20 seconds, you see that we once again we get a much more chaotic and a longer sample rate. So I'm going to switch that back to 10 for our purposes, because we're going to be doing something with a lot of samples here, and I want to keep this fairly sane. Even on my really robust studio system here, there is the possibility that this could crash, and I don't want to do that. So I want to make certain that I'm not overutilizing my RAM resources or my CPU resources as we're building this strand network out. All right, so this is pretty good. We've kind of got something that we want here, but now we need to set 2 more nodes up so that we can render this through Arnold and have a bit more control over what we see here. However, before we set those up, I'm going to start to kind of create the situation beforehand that I want to give me kind of the result that I want in the end. And in the end, I want a lot of these strands. So many strands that they almost look like solid matter. The issue with that is if I do this after I make these other 2 nodes, I'm really stressing the system. If I do this beforehand, I have just found through experience that it takes less resources for the system to process. So one of the ways that this system will sort of populate these nodes is right here in our create mesh torus. The more major segments I have, the more lines we'll get. So if I change this number 20 to 100, you see that we get more lines. If I change it to 1000, you'll see that we get more lines. I literally probably want this at around 10,000 right now. And again, I want to do this in such a way that it doesn't overstress the program. And you know, we always want to think of order of operations when we're working with this. And to be fair, it might take your system a little bit longer to populate this space with these strands. That's okay, just wait, it's worth the effort. So right now we're at 10,000. What happens if we put it to, say, 5, 0, 1, 2, 3, 50,000? Once again, give it a moment to catch up. And it shouldn't take too long, because once again, these are procedural geometry. We're not actually creating any faces or anything right here. Worst case scenario, I'll pull up our statistical usage. You can see that we're using a good bit of memory and some of the CPU. We're already done. Why it disappeared, that I don't know. That's a weird wild thing. Let me do a quick check. Sorry about that, guys. I just had to do a little bit of a refresh on my graphics drivers. They're a little out of date, to be fair. I do need to update them, but we can see now that I've got a lot of strands here in my viewport. Let's see if I can get this to respond. There we go. I really do need to update this. So you can see that we've got a lot of geometry in here. Although it's procedural, it's still taking up some memory. If we pull up our resources, you can see that it's using 37% of my memory. This system has 256 gigs of RAM, so that's a good bit of memory on here. If I did not have those resources, I would be probably a bit more conservative with those numbers that we punched in on the Create Mesh Torus. So what we're going to do now is since we've set that up, let's create those other two nodes that I talked about that we're going to need to be able to kind of render this out. The first is a set strand size node, and if we just hit set, and you can type in set strand, I just kind of like scroll down. Here we go. Where is it? Set QR. I'm doing the alphabet in my head. Set strand size profile right here. And let's also do an Arnold. All right, so give it a second. Once again, we got a lot of stuff happening right here. And honestly, I know a lot of you are working on laptops or maybe lower resource systems. You can be more conservative with these numbers. I'm going for something with quite a bit of visual solidity here. You can get just as elegant or just as experimental a result working with much lower numbers that don't stress your system quite as much. So once again, I'm going to hit the tab key and I'm going to do set, and let's do set Arnold. And we're going to do set Arnold strand settings. So I'll leave this up here for a second so you guys can see. We've got the set strand size profile node, and we've got a set Arnold strands settings node. And we're going to pipe through from vector field scope here into the strands input on set strand size profile. And then our out strands into the Arnold strands. And then from the out strands into the output right here. And what that's doing is it's going to give us the ability to set our strand size and then ensure that Arnold can render these strands in a manner that's commensurate with the render engine's abilities. So if I were to render this right now, the set strand size profile is set to 0.25. I'm going to change that a little bit. Here in the Arnold set strand settings, we do want to change this from mode override default to thick. Now that gives us the ability, once again, like I said, to change the size of these strands that comprise this organic shape here. So give it a second to process here. Once again, if I pull up and we look at what's going on, you can see that we've got a good bit of memory committed to this operation. The CPU is not quite as committed, not a big deal right here. It's already done. Set strand size profile, like I said, I'm going to set it to from 0.25 to about 0.1. That's just going to make these strands thinner. The other thing I want to do is I want them to taper at the end, but first I'm going to assign a shader, and we're going to render this out so that you guys can see, what I'm kind of going for here, and it might give you an idea as to what you're going for. And please keep in mind, this is the exact space in the tool set where you should be experimenting. We really want you to play with these numbers and come up with something that's more in keeping with the way sort of you're thinking about how things should look. All right. Sorry about this juddering here. Again, my graphic sampling is low so that I can stream this to record. Let's stop that. Boom, there we go. All right, so the first thing I'm going to do is I'm going to right click on this and I'm going to assign our favorite material, and that is an AI standard surface material. Now, if for some reason when you do this nothing exists, it's because you have not assigned a favorite AI standard surface material. To do so, you need to open your Hypershade, and here under the Arnold tab with the shader selected, we're going to right click on AI standard surface and you're going to add that to your favorites. That just allows you to work a bit more quickly and right click and add things in. Now I'm going to give this kind of a middle gray appearance and a roughness of about 0.6. So if we go about 0.6, And let's give it a light source. For us, we're going to go to our Arnold shelf here, and we're going to create a sky dome light. And anytime we create a sky dome light, let's make certain to come down under our visibility tab. And under camera, we're going to turn it down to 0. That's so that we get an alpha channel back here and our camera doesn't see this bright white background. I really don't want that there. In fact, I'm going to minimize our graph editor for a moment. I'll bring it back up so that we can look at what's happening here in the screen. So before we render, let's make certain to set things up the way we want. And that is, one, I'm going to open my render settings here, pull these from my other monitor. I'm going to make sure that I'm always in my full HD 1080 space, like so. And then in my viewport here, I want to go up to view, and under camera settings, I'm going to turn on my resolution gate. This allows me to actually see my compositional space so that I can kind of move my scene in such a way that I can create a composition that's visually interesting. Maybe like so. That'll be good for now. Now, let's pull up our render window, and I'll scale this so that we can see what's going on. And let's hit render, and really quickly we're just going to take a look at what we've done. And let's give a second for Arnold to populate all of this procedural geometry into memory. And there we go. So you can see now we have so many strands that it's creating this almost solid geometry. Now what could be interesting, I'm going to stop that render, let's minimize that for a moment, is if I decided to really zoom in and emphasize some of these areas. Now what I'd said earlier is we hadn't set our strand size yet, and so if you notice, it's a little hard to see, but our strands are ending kind of in a blunt end. I would much prefer them to taper off. So that's what this node allows us to do. I'm going to do our set strand size profile, and I'm going to click on profile here, like so. And it allows me to literally sort of shape this strand. I'm going to bring this down to 0. And that's so my strand will literally go from like a scale of 1, and towards the end, it will taper down to 0. So it'll come to a point at the end. Now this is going to take a second to populate. Once again, I've got a lot of stuff going on here. In fact, for the demo, it might have been better if I'd have set a lot lower setting here in our create mesh torus, but you know, it is what it is for now. So let's give it a hot minute, and all these things, as you can see now, well, maybe you'll see it in the render. Let's do this so that you can really see it in real time. If I zoomed in here, I guess you can't see too well, but these are all very blunt ends. And if we render now, you'll notice that the strand ends will come to a taper, the way an eyelash or a hair would, or something like that. You can see it here quite well. And so I could even make the strand bulbous in the center and tapered at the end, or tapered in the center and bulbous at the end. Any way I manipulate that strand profile, I can add points in and really kind of play around with it. And I've found that it's pretty kind of interesting to see what those results can be. And so here we are, we're zoomed in. This is our render really close, and this is our massive strand collection in here. Now let's up the ante a little bit. I'm going to minimize this for a second, and instead of using just a regular sky dome light, let's map an HDRI image onto here, and that'll allow us to talk a little bit about what we need to do that. So I'm going to file here, and let's go create that file node for an HDRI light. Here in Maya, I have a folder for my HDRI. I'm going to use just sort of one that's pretty normal for me. Under color balance, we always need to check alpha is luminance, like so. Back under here, I want to set the resolution to match the HDRI that I've downloaded, which was 4K. So our resolution is 4096, that's 4K. And I'm going to set the samples to a minimum of 3. Now, if I render this again, we'll see that our lighting is a much more interesting. Let's take a snapshot of our before. Let's render it again with the HDRI lighting the scene. Now we can see this is a much more interesting lighting scenario. And what's great is I can grab my HDRI, my sky dome light here in the background. Give it a sec, I'll stop that render just there so that we can move it. And I can rotate this sky dome light to give me sort of any angle that I want. Now, I'll generally switch to like top view or something like that. And maybe I'll rotate this a bit. I kind of want to find out where the key light is coming from on this HDRI. And so I'll render it, and in real time I'll start to move this HDRI light to see what gives us the best result. And this might not be the best HDRI for this particular image. Of course, I can kind of go through my collection and see which ones will work best. One of the things that people generally notice, however, is that we can't see our HDRIs the way we would see a normal image. And that is where Adobe Bridge comes in. So I'd like everybody to take a real quick look here. We're going to do a little bit of an aside. With Adobe Bridge active, and this is part of the Creative Cloud package, Adobe Bridge can actually, I'll let mine load up, give it a sec here. I've got Adobe Bridge going to my HDRI folder. Adobe Bridge actually lets us see HDRI, so I can browse them kind of in this manner. This is a really great way of having a visual representation of what I'd like to use. As you can see here, this is an HDRI St. Peter's light probe. It's one I've used quite a lot at St. Peter's Cathedral. I actually shot this one years and years ago, and then I found Paul Debevec, who invented the HDRI, had done a much higher resolution version, and I've used it for a lot of different things. Grace Cathedral, so on and so forth. I can go in and grab these HDRIs. So let's use maybe this one right here. I like this one. I want something with a really hard light. That'll be pretty good right there. Ballroom 4K. So I'll minimize that. Let's go and reload this HDRI. And I'm going to grab Ballroom 4K. Here we go. Right here. Whoops. Where are you? Boom. HDR file. Give it a second to load. And let's check our render with Ballroom 4K. All right. Once again, a much more interesting lighting scenario. I think I'm going to reset those transforms that I sort of did here to rotate our sky dome light. Let's hit stop for a second. I'd like to see, and I'm also going to make certain of another thing here that's really important. For format, I'm going to switch it from lat long to mirror ball. That's important just to get the HDRI to reflect in the appropriate manner. And here in my channel box editor, I'm going to reset that rotation back to 0. And let's take a look at our render now. Alright, it's not too bad. I like this lighting scenario. We haven't really put a texture or anything on this yet. All we're doing is rendering, and zoom in a little bit, our Strands network with a nice compositional choice and an HDRI image attached to it. The most important part of this is learning that, minimize that again, is learning that our Bifrost graph editor gives us the ability to really experiment with how we are adjusting these parameters let's say I adjust this now to 5, back down to 5,000. You'll see that this is a very different render. We've got a lot more sort of freneticism on the periphery than we had before. Render this one. So you can see that we're starting to split things off a bit more. And if I were to go into my Bifrost graph editor here, and under something like the vector field scope, if I were to change the flow line in seconds from say 10 seconds, I'm zooming out a little bit here. Let's see if we can do some of this in real time so you guys can see it. Let's change it to say 20 seconds. Give that a second to populate and update here in our render window. You can see we get a much more chaotic sort of shape here. And once again, I can, let's minimize that, move that over. I can move in on this composition and sort of recompose the shot in a way that is interesting to me visually. Here we go. And I'll full screen that so we can really kind of look at what's happening in here. Alright, so that's it for now. Now in the next tutorial we're going to talk about animating this system and actually adding textures to this and really giving it a little bit more sort of oomph than we've got now. But for the moment, hopefully this gives you a little bit of insight into working with the Bifrost graph editor, at least in this manner. We'll look at working with particulates and particle systems later, but for now just working with strands. Hopefully this is a nice way for you to get started creating abstract geometry and mathematically procedural images in Autodesk Maya. Alright, and as normal, remember to headbutt that like button.